Welcome to Mentivia. In this video, we're unlocking the secrets of the periodic table by exploring how electron configurations are beautifully mapped onto its structure. Hi, I'm Mark from Mentivia.com. Today we'll take a closer look at how the periodic table reflects the electronic structure of atoms. This isn't just a random arrangement of elements. It's a carefully designed visual guide that reveals how electrons fill energy levels and sublevels. Understanding this connection allows us to predict an element's electron configuration and, in turn, its chemical behavior. We'll explore how the table's layout mirrors atomic architecture and why it remains one of the most powerful tools in science. Let's dive in and decode the logic behind the elements. Let's start with the horizontal rows, known as periods. Each period number directly corresponds to the principal energy level, or N value, of the outermost electrons for all elements within that row. For example, every element in period 3 has its valence electrons residing in the third principal energy level. This simple correlation immediately tells us about the general size and energy of an atom's electron cloud. Now let's look at the vertical columns, which are called groups. For the main group elements, these columns reveal a crucial piece of information: the number of valence electrons. Valence electrons are those in the outermost shell, and they are the primary drivers of an atom's chemical reactivity. Elements in group 1, for instance, all possess one valence electron, while group 17 elements, the halogens, consistently have 7 valence electrons. This pattern is incredibly predictive. The periodic table is also neatly divided into 4 distinct blocks: S, P, D, and F. These blocks are named after the type of atomic orbital that is being filled with electrons as you move across that section of the table. This block structure is a direct consequence of the Aufbau principle, which guides the order of electron filling. The S block comprises the first 2 groups on the far left. For elements in these groups, the last electron added to their configuration enters an S orbital. This means elements like lithium and beryllium are busy filling their S sublevels, which are spherical in shape. Moving to the right, we find the P block, which includes groups 13 through 18. Here, elements are filling their P orbitals. Remember, P orbitals have that characteristic dumbbell shape. This block includes a wide variety of elements, from metals to nonmetals, culminating in the stable, noble gases. In the middle of the periodic table lies the D block, home to the transition metals spanning groups 3 to 12. For these elements, the D orbitals are being filled. These orbitals have more complex, often cloverleaf shapes, and their filling accounts for the unique properties of transition metals, such as their vibrant colors and variable oxidation states. Finally, the F block, usually placed separately below the main table, consists of the inner transition metals, the lanthanides and actinides. In this block, the highly intricate F orbitals are being filled. These elements are known for their unique magnetic and optical properties, often due to the complex nature of their partially filled F orbitals. Let's put this into practice with an example. Consider sodium. It's located in group 1, period 3. This tells us a lot. Being in period 3 means its outermost electrons are in the N3 energy level. Being in group 1 means it has one valence electron. Combining this, its valence electron configuration is 3s1. Its full configuration is 1s2, 2s2, 2p6, 3s1. This simple position on the table gives us its entire electron story. Now let's look at chlorine. It's in group 17, period 3. Again, period 3 signifies its valence electrons are in the N3 energy level. Group 17, being a P block element, means it has 7 valence electrons, 2 from 3s and 5 from 3p. So its valence electron configuration is 3s2, 3p5. The full configuration is 1s2, 2s2, 2p6, 3s2, 3p5. Notice how its position perfectly reflects its electron arrangement. In summary, the periodic table is much more than a chart. It's a sophisticated map of electron configurations. Periods tell us the principal energy level of valence electrons, groups reveal the number of valence electrons, and the blocks indicate which type of orbital is being filled. By understanding these connections, you gain a powerful predictive tool for an element's atomic structure and chemical behavior. Keep exploring, and you'll see how these fundamental principles underpin all of chemistry. Thanks for watching. If you enjoyed this video and want to dive deeper into science topics, head over to Mentivia.com. You'll find a wide range of free e-learnings, videos, and articles designed to expand your understanding and spark your curiosity. And if you're excited to keep learning with us, make sure to subscribe. There's plenty more coming your way.